In this video, I'm going to be working through the 3.4 homework exercises on WebWork. In this section, we're going to have polynomial functions, and we're going to divide them using long division or synthetic division by a linear factor that looks like x plus a number or x minus a number. The goal is to find factors of our polynomial functions. In problem number 1, we're asked to find the quotient and remainder using long division. Now, the expression in the numerator of this fraction is called the dividend, and then x plus 3 is the divisor. So we're dividing x plus 3 into the polynomial x squared plus 7x plus 15. And we're going to write the quotient and remainder here in WebWork. So let's work this out. In this expression, we write the dividend under the division sign. The expression x plus 3 is called the divisor. And we're going to be dividing x plus 3 into x squared plus 7x plus 15. So to do this, we only divide the leading terms. So we're going to take x squared and divide it by x and write the answer up here in the quotient. So x squared divided by x is x, and I put it here. And it's important to keep all the terms in the same degree in the same column. So I have a x, I'm writing the x over the 7x because they have the same degree. So I did x squared divided by x and wrote x. And now we multiply x times x plus 3. So x times x is x squared. X times 3 is plus 3x. And then the next step is that we subtract this whole expression from the dividend. So x squared minus x squared will cancel. So in each step, the first terms should cancel. If you're doing this right, the first terms will always cancel. And I get 7x minus 3x, and it gives me 4x. And then I bring down the next term, plus 15, and we start again. So that's one step of the long division. So again, we look at the first terms, 4x, and divide that by x. So 4x divided by x is plus 4. And now we multiply. 4 times x plus 3. 4 times x is 4x. 4 times 3 is 12. And when I subtract this whole expression from the top, 4x minus 4x cancels. 15 minus 12 is 3. And when we get down to a constant term, there's no more terms to bring down, then we're done. So this expression is the remainder. The remainder is 3. And the quotient is x plus 4. We've just shown that x squared plus 7x plus 15 divided by x plus 3 equals x plus 4 plus the remainder 3 over the divisor x plus 3. So another way of writing this expression, if you multiply both sides by x plus 3, we've just shown that x squared plus 7x plus 15 equals x plus 3 times x plus 4 plus the remainder of 3. So those are a couple ways that we often write our answers to long division problems. But in WebWork, we have to enter our quotient, x plus 4, and our remainder, 3. And we get the correct answer. So this was number 1. In the next problem, we're going to do the same thing. Now we have a bigger dividend. We have x cubed minus 12x squared plus 36x minus 17, all divided by x minus 4. So I'm going to set this up in long division. Okay, so I have this all set up. I have my dividend underneath this division symbol, the divisor outside x minus 4, and we're going to start by dividing x cubed by x. X cubed divided by x is x squared, 1x squared, so I'm going to put that in the quotient. And now when we multiply, x squared times x is x cubed. X squared times minus 4 is minus 4x squared. and then we subtract this expression. So be careful with all these minus signs. X cubed minus x cubed cancels. Negative 12x squared, subtract negative 4x squared. That's like negative 12 plus 4. So I get minus 8x squared. Now we bring down the next term, 36x. And start again. So I'm only dividing the leading term, minus x squared, divided by x, is minus 8x. When I multiply, I get negative 8x times x is negative 8x squared. Negative 8x times negative 4 is positive 32x. And I subtract this expression. So the negative 8x squared minus negative 8x squared, those will cancel. 36x minus 32x is 4x. And I bring down the minus 17. Then the last step would be 4x divided by x. 4x divided by x is 4. So when I multiply, 4 times x is 4x. 4 times minus 4 is minus 16. And I subtract. The 4x minus 4x cancels. Negative 17 minus negative 16 is like negative 17 plus 16. So I get a remainder of minus 1. So when I come over to web work, the quotient is the expression on top, x squared minus 8x plus 4, and the remainder is minus 1. And we get the correct answer. Let's move on to problem number 3. Now in problem number 3, we're asked to use the factor theorem to show that x minus c is a factor of this polynomial function where c is equal to 1. So what this is saying is that if x minus c is a factor of this polynomial, then when I divide p of x by x minus c, I should get a remainder of 0. So this is really the purpose of doing division and like long division and synthetic division, is to factor these degree 3 polynomials that are and larger polynomials. So let's set this up using long division. So here is the setup. We have x minus 1 because we're given a value of c of 1. We're dividing x minus 1 into x cubed minus 4x squared plus 6x minus 3. So again, we're going to divide x cubed by x. X cubed divided by x is x squared. And I multiply x squared times x is x cubed. X squared times minus 1 is minus 1x squared. When I subtract this expression, I get minus 4x squared minus a negative x squared. So that's like minus 4 plus 1. So I get minus 3x squared. Bring down the plus 6x. And start again. Minus 3x squared divided by x is minus 3x. When I multiply, I get minus 3x squared. Minus 3x times minus 1 is positive 3x. And when I subtract this expression, I get 6x minus 3x is 3x. And the 3x squareds will cancel. Minus 3x squareds will cancel. Bring down the minus 3 and start again. 3x divided by x is positive 3. 3 times x is 3x. 3 times minus 1 is minus 3. Notice we have the same expressions here, so when I subtract, I will get a remainder of 0. So this proves that x minus 1 is a factor of p of x because I end up getting a remainder of 0. So we've actually factored p of x. So we have p of x, which was x cubed minus 4x squared plus 6x minus 3. We've actually factored it. We've actually shown that it equals the divisor x minus 1 times the quotient x squared minus 3x plus 3. So if we had a remainder, we would add it here, but you notice that the remainder is 0, So when we write plus 0, that doesn't contribute anything, so we don't write that. And so what we've actually done is we've actually factored p of x. So this is the point of long division. If we can find a divisor of the polynomial p of x, but using long division, this will enable us to factor larger degree polynomials, like degree 3 polynomials. So back in web work, our quotient is x squared minus 3x plus 3, and the remainder is 0. Here we go. Let's move on to problem number 4. In problem number 4, we're going to divide f of x by g of x using synthetic division. So this is a quicker way to divide a polynomial by a linear factor x minus c. So let's set up the synthetic division. So in synthetic division, our divisor is x minus 2, but we're only going to be using the coefficients. So in this case, if x minus 2 is the divisor, we're just going to be using the number 2 for our divisor. And then in our dividend, we have minus 5x to the fourth plus 9x cubed plus 3x squared minus 9x minus 8. We're going to only be using the coefficients. So we write down the coefficients: minus 5 plus 9 plus 3 minus 9 and minus 8. And it's important to note that if you're missing one of these degrees, we always have to put a 0 placeholder in. So we're not, like, if there were no x cubed terms, I would put a 0 for the coefficient of x cubed. Then to set this up, it's going to look different. I'm going to have my divisor 2 over here, and this is the way I would set up the rest of the synthetic division. So in synthetic division, by using 2 instead of x minus 2, it switches all the operations to addition instead of subtraction. So minus 5, to begin this, I take the minus 5 and I bring it straight down into the quotient. The quotient is going to be underneath this symbol here. So minus 5 goes straight down, and now I do the multiplication. 2 times minus 5, and I write the answer here. So 2 times minus 5 is minus 10. And now I add 9 plus minus 10 is minus 1. So that's one operation. Then I do multiplication again. 2 times minus 1 and write it here. 2 times minus 1 is minus 2. And I add, I get 1. 2 times 1 is 2. Add, I get minus 7. 2 times minus 7 is minus 14. Add, I get minus 22. So minus 22, this number is the remainder. And then these coefficients, minus 5, minus 1, 1, and minus 7, this is your quotient. And these are the coefficients of the quotient. So I'm going to convert them back. I divided a degree 4 polynomial by a degree 1 polynomial, so you'll end up with a degree 3 polynomial. Minus 5x cubed minus 1x squared plus 1x minus 7. So there's your quotient and your remainder. Back in web work, all right, my quotient is minus 5x cubed minus x squared plus x minus 7, and the remainder is minus 22. So the next problem involves synthetic division as well. In problem number 5, it says to use synthetic division and the remainder theorem to evaluate p of c, where we're given this polynomial function p of x, and we're given a value of c equal to 2. So the remainder theorem is telling us that when you divide a polynomial by x minus c, the remainder actually equals p of c. So in this expression, we're going to be dividing p of x by x minus 2. And in synthetic division, we're going to use the number 2 as our divisor. So for number 5, our divisor is going to be 2. And our coefficients of p of x are 1x cubed minus 9x squared plus 16 minus 12. So I bring the 1 straight down into the quotient. 2 times 1 is 2. And I add, I get minus 7. 2 times minus 7 is minus 14. Add, I get 2. 2 times 2 is 4. Add, I get a remainder of minus 8. So what we've just shown is that p of x equals our divisor, x minus 2, times the quotient, x squared minus 7x plus 2, plus a remainder of minus 8. So we see if we plugged in 2 into this polynomial, you would just get 2 minus 2, which is 0. So all this stuff doesn't even matter because you'd be multiplying times 0, minus, and then you have a minus 8. So all this stuff just goes away, it just becomes 0. And so we see that p of 2 equals negative 8. So that is what the remainder theorem is saying, is that the remainder equals p of 2. So whenever you're dividing a polynomial by x minus c, the remainder is p of c. So we have our quotient and remainder, and we know that p of c is equal to the remainder. So back in web work, our quotient was x squared minus 7x plus 2. The remainder was minus 8. And then whatever you get for the remainder, that is the same as p of c. So the remainder equals p of c. There we go. Let's move on to problem number 6. So in this problem, we're asked to use synthetic division, and we're given a root, that is a solution to this equation. If x equals 7 is a solution to this equation, then we know that by the factor theorem that x minus 7 is going to be a factor of this polynomial. So we're going to use synthetic division, divide by x minus 7, and we'll get a factored form for this equation. And then we're going to use that result to completely factor the remaining parts of this polynomial. So our goal is to factor this polynomial as x plus a times x plus b times x plus c. So we're going to be using a divisor of 7 in our synthetic division, and our polynomial is 1x cubed minus 2x squared minus 31x minus 28. Now, we're told that 7 is a 0, or a root of this polynomial, so we should end up with a remainder of 0. So I bring down the 1. 7 times 1 is 7. Adding, I get 5. 7 times 5 is 35. Add, I get 4. 7 times 4 is 28. Add, I do get a remainder of 0. So our quotient is x squared plus 5x plus 4. And so what we've actually just shown is that x cubed minus 2x squared minus 31x minus 28 can actually be factored, as our divisor is going to be x minus 7. Remember, we divided by 7 in synthetic division, so the factor would be x minus 7 times our quotient, which is x squared plus 5x plus 4. And then the remainder is 0. So again, this shows that we've actually factored the polynomial. So we got our x minus 7 from the divisor, and we get our x squared plus 5x plus 4 from the quotient. So now that we have one factor of this polynomial, the remaining trinomial factor is a factorable quadratic. And so we've factored these before. We still have the factor of x minus 7. If this trinomial factors nicely, which it should, It'll be two linear factors with leading coefficient x and x, because x times x gives us x squared. So we're looking for two nice integers that multiply to 4 and add to 5. Well, 4 times 1. So x plus 4 times x plus 1 would be the remaining factors of our original large polynomial. So using division, we found one factor, and then using our factoring techniques, we factored the remaining trinomial. So back in web work, we have a factorization that looks like x plus a times x plus b times x plus c. And so we just have to enter the numbers -7, +4, and +1 for our solutions to the web work problem. So again, we don't have to solve this equation. We don't have to factor in, do anything else. We just need to factor this, and we enter our answers, the -7, the 4, and the 1 for the a, b, and c of our three factors, separated by a comma. There we go. So this is a good example that shows the power of polynomial division using long division or synthetic division to factor large polynomials. And this finishes the 3.4 homework.